everyone, welcome back to Leetcode Simplified. I'm Alan and today we're solving Leetcode 367 valid perfect square, the simple and logical way. You're given a positive integer x. Return true if x is a perfect square of some integer m. In other words, if you can find an integer m such that m times m equal x, return true. By the way, m is called the perfect square root of x. Here is our approach. We will use a binary search because it is optimized for finding breakpoints in monotonic range. In the case we are searching for breakpoint m, such that m times m equals a given x in a sorted dataset 1, 2, 3, and so on. That's perfect for binary search. But first, let's take care of this super easy special case. 1 is a perfect square because 1 equals 1 times 1. Now, here is our main focus, binary search. For any x larger than 1, the perfect square root cannot be larger than half of x. So initially, we search in the range between 2 and half of x. Calculate the middle of that range and compare middle times middle to x. If equals, then middle is m, the perfect square root, and we return true. If middle times middle less than x, then we want to search the perfect square root on the right side of the middle. How to do that? Move the left boundary to middle plus 1. Likewise, if middle times middle is greater than x, we want to search the perfect square root on left side. And how to achieve that? Set the right boundaries to middle minus 1. We will repeat these above steps again and again until we find the perfect square root, or until left boundary and the right boundary cross each other. Then stop the process and return false, because there is no perfect square root for that given x. Let's animate the below example step by step. We're looking for the perfect square root of 16, if any. Let's say we are smart. Our intuitive says the perfect square root of x cannot be larger than half of x, 16, which is 8. So we start the binary search from 2 to 8. Initially, set the left boundary at 2 and the right boundary at 8. The middle is 5, and 5 times 5, 25 is greater than 16x. So the perfect square root, if any, must be smaller than 5. So we move the right boundary to 4. So that we can search the left side of the middle 5. In the new search range from 2 to 4, the new middle is now 3. And 3 times 3, 9, is less than 16. So the perfect square root, if any, will be larger than 3. So to search the right side of 3, we move the left boundary to 4. In the new search range, both left and right point to 4. So then the new middle is also point to 4. 4 times 4 equals x, 16. It means we found 4 is the perfect square root, and 16 will be the perfect square. Return true. Now that we understand the logic, let's implement it in Python. First, if x equals 1, then we return true because x is a perfect square. Initially, we set the search range from 2 to half of x. As long as the left boundary do not cross the right boundary, do the following. Find the middle and compare middle times middle to x. If equal to x, return true because x is a perfect square. If middle times middle is less than x, we need to search the right side of middle. So move left boundary to middle plus 1. And finally, if middle times middle is greater than x, we need to search the left side of middle. So set the right boundary to middle minus 1. If the left and right boundaries cross each other, the while loop will exit return false because there's no perfect square root. And that's how you check if a number is a perfect square. Fast and clean. Let's hit the submit button. Boom! Accepted. Binary search gives us the answer with no need for square roots or floating point math. Just smart logic and integer precision. If this makes sense, give it a like and subscribe for more simplified Leetcode guys. I'm Alan and this is Leetcode Simplified. Catch you in the next one.